So we've talked about having nonlinear systems of equations and how to solve them using either the elimination method, substitution, or the addition method. So now we're going to talk about how to do this with an application problem. So if you notice, a right triangle has a hypotenuse measuring 13 inches. That's kind of nice of them. They told us some information. So we have this right triangle, and we know that it's a right triangle because I put this, and it tells me that the hypotenuse, the side across from my right angle, is 13 inches. The area is 30 square inches. So part of this tells me I have to know how to find the area. Well, remember the area of a triangle is 1/2 the base times the height. Well, my base is here, my height is here. I don't know either one of those. But I do know the area, and the area is 30. It's equal to 1/2 times my base times my height. To get rid of that fraction, multiply both sides by a 2. That gets rid of these things, okay? Leaving me with 60 is equal to my base times my height. Now that still doesn't help me, doesn't tell me what to do with this 13 inches, but remember a right triangle, the sides, a squared plus b squared equals c squared. Hypotenuse is over here. So I know that this is 13 squared. My a is just going to be my base. My b is going to be my height. So I have base squared plus the height squared is equal to 13 squared. So base squared plus height squared is equal to 169. Can't really solve this one for b or h, but I can this one. What I do is I'm just going to divide by h. And that will give me that 60 divided by my height is equal to my base. Now I can plug that in over here, because I can say 60 over h, that quantity squared, plus h squared is equal to 169. Now I know we don't really like these things. Remember when we square fractions, we square the numerator and we square the denominator. This actually has a denominator, so it's a rational equation. So I need to get my LCD, which is going to be h squared. So I'm going to multiply each thing by an h squared. Remember, I multiply every single term by this h squared. So I have my LCD times my regular h squared is equal to 169 times my h squared. Remember what happens? These cancel, which leaves me with 3,600 plus an h to the 4th is equal to 169 h squared. I need to get everything to one side of my equal sign, so I'm going to subtract this 169 h squared, so it's going to be h to the 4th minus 169 h squared plus 3,600 equals 0. Now we have an h squared in there. Don't panic, okay? Factor out your equation just like you would if you had h squared minus an h, okay? The only difference is this middle term is what goes right here, okay? Instead of just an x or a y, we actually have h squared. Numbers that multiply to give me 3,600 and add to give me a negative 169 is going to be a negative 144 and a negative 25. which is really nice in this case. Because now I have h squared minus 144 is equal to 0, and h squared minus 25 is equal to 0. Add 144, so I get this. I've got to take the square root of both sides, positive and negative. So h can be a positive or negative 12. But what are we talking about? This is the height of my triangle. Can a height ever be negative? No. So I know that h, in this particular case, has to be a positive 12. Now let's look at the other one. It's equal to 25. Take the square root of both sides, positive or negative square root. And so I get that h is equal to a positive or negative 5. But again, we're talking about the height. Height cannot be negative. So h is equal to 5. So I have two possible values for my height. I'm going to plug those back in to find my base. My base is going to be 60 divided by one of my h's, so let's go with 12 first, equals my base. So 60 divided by 12 is 5. So when my height is 12, my base is 5. You kind of already see the pattern here, but let's go ahead and do 60 divided by 5 is equal to my base. Well, 60 divided by 5 is 12. So my base is 12. Height is 5 when the base is 12. So in this particular case, the length of each leg, the lengths, if I could look at this correctly, the lengths of the legs are 5 inches and 12 inches. Because it doesn't matter, either way I go, one's 5, one's 12. Okay? So try some additional application problems with these nonlinear systems of equations, and then let me know if you have questions.